My fabulous minions. Video number 6, mole to mole conversions. This is where the rubber is going to hit the road and I can go from moles to grams and grams to moles quickly. That's what we basically need to be able to do. We're going to find that the exact ratios of compounds in a balanced chemical equation is going to act like our recipe, and I'm going to use this recipe to go from grams to moles. So, notes first. A chemical equation is a recipe, of course. I'm going to use the coefficient to tell me how many reactants and products I should have, and then I can get some specific ratios. So you can see in this first example, I need 3 eggs to every cup of flour to every 2 cups of sugar to make 24 cookies. Well, if I needed to make 48 cookies, what would I do? I could use that ratio of 24 to 48, which is double, and double all my ingredients. I can also, if I need to make 36 cookies, which is 1.5, I can use that as a ratio to figure out what I need to do to go in as far as what I need to do to my reactants. The other key is that if I need 3 eggs to make 24 cookies and I only have 2 eggs left, oh boy, now I have to change the whole thing around. So these are the kind of things and the kind of games we can play, okay? So in interest of keeping this thing going, oh yeah, if I had to bake 48 cookies, I would need to double it, okay? Method for solving mole-to-mole problems, we need to set up our proportion. Another word for proportion is ratio. Okay, ratio. I'll write that right here. Ratio. All right, so I need 3 eggs, 1 cup of flour to 2, is that sugar, right? 2 cups of sugar to make the 24 cookies. Well, if I'm going to make 48 divided by 24 is what over 3? Because I have 3 eggs. 3 eggs. So what do I need for eggs now? 6. All right, it's going to be double. This is 48 divided by 24 is 2. So that goes 2 equals x over 3. I'm going to multiply both sides by 3. X equals 6. That's the 6 that I put, whoopsies, that I put right there. Okay? If you have 10 eggs and an infinite amount of sugar and flour, that's because I don't want to run out. How many cookies can I make? Well, 10 over 3 is a ratio, and I have an x here. In this case, because of this equal sign, I can cross multiply. That's going to be 3x equals 240. Divide both sides by 3. 3 goes into 24. How many times 8? Bam, 80 cookies. Yum. So you have another example to consider. And now it's going to go right into a chemical compound. So it says, how many moles of nitrogen gas, N2, I have 1 here. Remember, it's not there, it's 1. Would be needed to produce 10 moles of ammonia. Well, it says I have 2 there. So let me go 10 over 2 equals, sorry, my equal sign came up bad, x over 1. And that 1 mole is this moles of nitrogen. Okay, so the key when you set these up is the ones that come from my equation are on the both on the denominator. I can't have one in the denominator, one in the numerator. It actually works if I flip the proportion, as long as I keep them the same. So this 2 and the 1 came from my balanced chemical equation. So that I put them in the denominator, they need to stay there. I can cross multiply. There it is. Cross multiply. I'm going to get 2x equals 10. Divide both sides by 2. X equals 5. So I will need, it says how many moles of nitrogen? I will need 5 moles of nitrogen. Okay, so I'm just setting up proportions and ratios based on what my recipe was. So here's another example for practice. I have 12 moles of C3H8 react completely. How many moles of H2 are formed? I'm going to walk you through the first one, and you're going to do the next 2. This should be a 1, of course. So I have 12 over the 1 that's given is going to equal x over the 4 that's given. Do a little cross multiply, and I have x equals 48. Done. You got 2 more to practice to see if you can do what I just did over and over and over again. Oh, look, we have more practice. Yay. All right, let me do number 5. It says I have 9 moles of ammonia, and then I look up here, ammonia here is there. I have 2, so that's going to be 9 over 2 is going to equal how many moles of H2? So this 2 and the 3 are in the balanced chemical equation here, so they need to be in the same denominator, numerator, whatever I picked. So it's going to be in the denominator with an x up here, and this multiply sign, of course, is not there. It should be an equal sign. Now I can cross multiply. This goes to 2x equals 27, I believe. Divide both sides by 2. X is going to equal 13 and a half moles of H2. There we go. So you guys need to finish your practice problems doing the same model I did. There is lots of practice in the practice packet, 20 through 29. The good news for you there is I took out a bunch of those pages, so it's something like 20 through 22, and then like 27 through 29. It's not nearly 9 pages, so don't freak out about that. Plus, there's also no CASA learning. So now we can go from mole to mole, okay? And then the thing that is not apparent in the notes and kind of comes into the practice, though, is that we already learned how to go from grams to mole. So I taught you how to go from grams to mole earlier. Now I taught you how to go from mole to mole using those ratios. So now you should actually be able to take those two and go from grams to moles, like grams of A to moles of B, following that step-by-step process. I can convert one into the other. All right, so that's the end of video 6. See you guys in class.